All right, the next set, 9, 10, 11, 12, says, what is the reaction showing solid aluminum 3 hydroxide trying to dissolve in water? And what is the KSP expression? All right, so aluminum hydroxide, I write down AlOH taken 3 times. And you know that that's a typo on my part. That's not there. You just think you see that, but you really don't. Aluminum hydroxide solid in equilibrium with aluminum plus 3 and 3 hydroxides, yes? And these are both aqueous, but you don't have to write that in because when you have ions with charges, it's understood that they're aqueous. But I'll write them in for us. That's all they're asking for in the first question in number 9, yes? Okay. Says number 9 on your paper, says number 1 here because I did a cut and paste and it just changed it. All right, so Nyreek, help me out. KSP expression, what would you write?
Bracket AL, plus. No, not plus, just right out of bracket.
Thank you.
OH minus.
All right, so a power of 3, yes? Okay, so we can do 9 and 10. Now number 11. Why did I ask you not to jump ahead and do number 11 on your own, Matt? Okay, what does saturated mean? What does saturated mean? At equilibrium. And you have that's a teaching moment today. A saturated solution means it has reached its equilibrium spot. But that's what they're going to use verbiage-wise when they get to KSP stuff. They're going to say saturated versus reaches its equilibrium spot. So you have to know they mean the same thing. Okay? So saturated solution means it's achieved equilibrium. It's gotten to achieved equilibrium. It's gotten to the E. All right, Abby, question. No, that is not the difference. No. Okay, Abby, what is the difference? Oh, they gave you grams per liter? How dare they? Great Mighty Mountains. They gave you grams per liter instead of moles per liter. How can I make it moles per liter, Great Mighty Mountains? I'm not at the Mighty Lakes yet. I'm only in the Great Mighty Mountains. Thank you. Great Mighty Mountains means divided by molar mass. Divided by molar mass. All right, so I come up here and I say, okay, I need to change that to moles per liter. So I divide it by the molar mass so that I can turn 2.8 times 10 to the minus 7 grams per liter into moles per liter. Anybody do that yet for me? Someone do it for me now, huh? 10 to the negative 5? 13. 2.8 times 10 to the minus 7 divided by 78.03. Yeah. Like, I know that negative 9. Okay. All right. So now that gives me my value of x, if you will. That is my x value. When we go down here to the ice chart, z, 0, 0, minus x plus 3x. That gives me my x value, and then I can multiply it by 3 to get my 3x value if I needed to or wanted to. Okay? So in my ice chart, ICE, we end up having z minus x, which we say is approximately going to end up just being z. And then we have x, and then we have 3x. Agree? Okay, so let's go plug in our x's then into the KSP expression and then use our x value of 3.589 times 10 to the minus 9 instead of the 2.8 times 10 to the minus 7 grams per liter. We want moles per liter. We want molarity values. So I come up here and I say x, and I say 3x cubed. Can we simplify that? Okay, so Hayden, what is 3x raised to the third power? X times what? What is 3x raised to the third power? 27x to the third. Everybody see that? If you take 3x and it's in parentheses and you cube it, you get 27x to the third, yes? Because 3 times 3 is 27, yes? Okay, so what's x times 27x to the third? Okay, not quite plugged in yet. What is x times 27x to the third? 27x to the fourth. That's important. I want you to put that in the brain right there. Why? Because if you have a 1 to 3 mole relationship between ions or a 3 to 1 mole relationship between ions, KSP will always be equal to 27x to the fourth, where x is the soluble piece, the amount that does dissolve. Okay, question? We're assuming 1 liter all the way through in all these problems, yes. Yes, we are. Okay, so now I can come down here and I can say KSP is going to be equal, and Matt, hold that thought for a moment because I'll come back and ask you for the answer. 27 times 3.589 times 10 to the negative 9 cubed. Not cubed, excuse me. Whoop, my fault. Erase to the fourth, Ms. Matney. We're already past the cube. To the fourth. Thank you. Okay, there we go. There we go. All right. So, Matt, you have that answer?
Yeah.
Okay, and it is? Negative 33. Great time of day. Does that speak to you? It speaks to me? Like not TPF, like very much not ever TPF, right? What kind of delta G? Positive. Okay, doesn't have an E cell. None of these in this chapter have an E cell because nobody's charge changed. Nobody's oxidation number changed, so no E cells. All right, does this make sense? All right, so the hard part. Who else has this 1 to 3 relationship? Oh my goodness, let's see if we can use the brain. Who else besides aluminum hydroxide has that same relationship? So aluminum hydroxide has KSP of 4.5 times 10 to the minus 33. All right. Next. Iron hydroxide, Fe iron 3 hydroxide specifically, because there's iron 2 and there's iron 3. All right, what's his KSP? Ooh, 2.5. Ooh. Okay. Who else has a 3 to 1 or 1 to 3? We got aluminum hydroxide. Calcium carbonate's 1 to 1. How about silver phosphate? Anybody see a silver phosphate on there? But strontium carbonate has 1 to 1 ratio. I'm looking for a 1 to 3 ratio. So let me look up for you silver phosphate real quick. Silver phosphate is 1.8 times 10 to the minus 18. Okay? All right, so let's just stop there because there's not a lot of 3 to 1s or 1 to 3s. But why did I put that one up there? Does it have to be 1 to 3? Can it be 3 to 1? Yes. It doesn't matter whether the 3 is on the first ion or the 3 is on the second ion subscript-wise. 3 to 1, 1 to 3 is still going to be ultimately KSP equals 27x to the fourth. Ultimately. Got it? All right, so Matthew, which one of these is least soluble? Compared all 3 of these, which one is less soluble? Okay, so he's less soluble. Mariah, not Miranda. Mariah, who's most soluble? Okay, so the silver phosphate is the most soluble. And I can do that because they have the same mole relationship. Yes? Okay. Now, how is that going to be different from this question? This is something totally different from what we just encountered because I did 3 examples with you. And now we have this example. They gave you KSP and they gave you the concentration of magnesium.